Welcome to the video for Chapter 9, Lesson 7, Perimeters and Similarity. By the end of this video, we should be able to answer the question, how does a scale factor help us find perimeters of similar triangles? We've already learned a lot about similar polygons and similar triangles and their proportional relationships of their sides. It turns out the same can be true about their entire perimeters. If two triangles are similar, then the measures of the corresponding perimeters are proportional to the measures of their corresponding sides. Let's use that information to answer this question, finding the value of each variable. This says the perimeter of DEF is 90 units, but that ABC is similar to DEF, so we can find the value of each variable by setting up a proportion with their perimeters. Knowing the side length for each side in triangle ABC, I have determined that the perimeter of that triangle is 60. So now we have two sets of matching corresponding information, their perimeters. So if I say that the perimeter 60 is proportional to the 90, the same way that the 26 is proportional to the x. So 60 over 90, small triangle to big triangle, is the proportion that we can use for 26 to x, small triangle to big triangle. Now we can cross multiply and solve for x. So x equals 39, and that's the value of this side. And so I'm going to continue to use the perimeter ratio to help me find the y using the 10 and the z using the 24, because that's with corresponding sides. So we use the proportion for the ratio of their perimeters and their corresponding sides to find that x equals 39, side y is 15, and side z is 36. This particular problem is really the same setup. Triangle BOY is similar to triangle MAN. We know the perimeter of triangle BOY is 18, and we can calculate the perimeter of triangle MAN by adding all the sides together and getting 63. So that's our perimeter, and then we're supposed to find BO, so I'm going to make that X, OY, I'm going to make Y, and YB, I'm going to make Z, and we can set up the proportions the same way that we did in the previous example. So three pretty simple proportions to cross multiply and solve. Side X or BO is 6, side OY or Y is 8, and side YB, which we use Z, is 4. Proportional information using a phrase or term called scale factor. Let's take a closer look at what that is. Scale factor is a constant of proportionality. It's the ratio of corresponding sides. In general, a scale factor describes the relationship between two similar shapes. Now, the examples that we're going to be finding the scale factor between these similar polygons, these examples are coming from our notes in previous lessons so far in Chapter 9. So these are not new shapes. These are similar polygons. And so all I'm going to do is set up the ratio of corresponding sides. So I'm going to match the 4 with the 8 and the 5 with the 10 and the 6 with the 12. Now, if we are looking at the scale factor from ABC, triangle ABC, to triangle DEF, then this is what we have set up here, because ABC is on top and the numbers from DEF are on the bottom. So all three of these numbers, all three of these ratios simplify to 1/2. So we would say that the ratio or the scale factor between ABC and DEF is 1:2. And we do normally write it as a ratio like that with the colons when we are stating scale factor. But the fraction is also true, and that's what we will use when it comes to actually calculating things. But this scale factor from triangle ABC to DEF is 1:2. If we were going to ask for DEF to ABC, then it would be 2:1. So order does matter. So if we look at 7 to 14 and 3 to 6, it looks like that's going to be the same thing. 7 to 14 and 3 to 6, they both simplify to that same 1 to 2 ratio. That's the scale factor. Looking at example C, the numbers are a little bit more complicated. So 24 to 18, 28 to 21, and finally 20 to 15. So we would use our calculator or whatever it is that we needed to do. I do know that they're similar, so I know that they are all equal. And so I'm just gonna focus on the fraction that I can answer or simplify quickly without a calculator or worrying much about errors, and that's the one that I'm dividing by 5. So that ratio simplifies to 4/3. So the ratio from triangle ABC to UTV, that scale factor would be 4 to 3. So the first examples we're using or finding the scale factor, and now we're going to start using the scale factor to find missing side lengths. Now in this example, it says triangle DEF is similar to GHI, and I am just drawing two triangles. I have no idea which one is larger or smaller than the other one. I'm just drawing triangles that are two different sizes, but obviously similar in shape. So we have a scale factor of 3 to 4, and I guess actually that does tell me that my DEF is going to be the smaller one and the GHI is going to be the bigger one, simply from that scale factor. So if DEF has a perimeter of 24, then we can use the 3 and the 4, the 3, the 4, and the 24, and I'll use a P for this proportion equation to solve for the perimeter of the larger triangle. So we got the perimeter of GHI to be 32. Now the only thing I'm going to point out really quickly here is just the way that I have drawn this diagram, this information. I was actually tempted to use the proportion equation 3 over 24 equals 4 over P. And I was tempted to do that simply because of my red writing here. 3 is literally on top of 24, and the 4 is on top of this P value. And you are allowed to do that. There is room for movement when you set up the proportion equations, as I have shown you before. Notice that these are acceptable because either way, I get 3 times P and 4 times 24. And so if I solve this blue proportion, I would get the exact same cross products and answer for the value of P. The second problem is just an extension of this information, so DEH is still similar to GHI, but now we are given GHI's perimeter is 24, and we need to find the perimeter of DEF. And so that's really just paying attention to where the 24 and the P belong. And so if this were the case, where the perimeter of GHI is 24, then DEF would be 18. This final example looks at a pentagon, which remember has 5 sides, and it's similar and it has a scale factor. So we're just going to be setting up the same way we were setting up with our other proportional relationships. So BC has a side length of 12. What's the length of NO? Now, first thing I want to just remind you of is that you notice how that BC those letters are next to each other in the pentagon's name, just like NO are next to each other in the pentagon's name for that one. So I know that these are corresponding sides because BC and NO are in the same spot on their name. So I am allowed to use the scale factor of 2 to 3, and using the 12 for BC, I'm going to put that up top, and then I'm going to use an X for the NO. The 12 has to be up top because when you are given a scale factor of 2 to 3, that order matches with the order in which that the statement is said. So this pentagon is similar to this one by 2 to 3. So ABCDE to MNOPQ, 2 to 3. So the 12 is coming from BC. The X, or the missing piece, is NO. So this has to be the relationship that we set up to cross multiply and solve. So X is going to equal 12, or the length of NO is 12. Now, if side PQ, still paying attention, 2/3, well, PQ is now in the second pentagon, so I'm going to put the 15 at the bottom. And the length of DE, again, just noticing that those letters are in corresponding spots, so I know that their sides are actually in corresponding locations. So I'm going to put the X, or in this case I'll just use a Y so it is a different variable, and we'll cross multiply and solve for the length of DE. So the length of DE would be 10. This concludes the video lesson for Lesson 7, Perimeters and Similarity. So how does a scale factor help us find perimeters of similar triangles? The perimeters of similar triangles are proportional to the scale factors of their sides.